Dear students, Assalamu alaikum. It is fourth week and we are already having chapter number 4, the turning effect of the force or the torque. And the content of this week are in front of you: the principle of moments, center of mass, center of gravity, couple equilibrium and states of equilibrium. We already have studied the concept of the torque being a vector quantity and the concept of the couple. We have already studied a little bit. Now I will explain all these concepts one by one in the next slide. And the objectives of this week are: student will be able to define principle of moments and also explain the principle of moments, and they will able to answer the question according to the board pattern and define center of mass, define center of gravity, define couple, and understand the concept of equilibrium and conditions for equilibrium. And the last is the understand the states or types of equilibrium. The first topic is principle of moments, and before going to explain the principle of moments, I would like to quote an example. A force that turns a spanner in the clockwise direction is generally used to tighten a nut. The torque or moment of the force so produced is called clockwise moment. And on the other hand, to loosen a nut, the force is applied such that it turns the nut in the anti-clockwise direction. The torque or moment of the force so produced is called anti-clockwise moment. A body which is initially at rest does not rotate. If sum of all the clockwise moments acting on it is balanced by the sum of all the anti-clockwise moments acting on it, this is known as the principle of moments. And so now I will define the principle of moments, which is in front of you written. A body is balanced if sum of all the clockwise moments acting on it is equal to sum of the anti-clockwise moments acting on it. So our second topic is center of mass. Students, I will also explain this through an example. It is our common observation that the center of mass of a system moves as if its entire mass is confined at that point. A force applied at such a point in the body does not produce any torque, that is, the body moves in the direction of net force without rotation. And now consider a system of two bodies. One is lighter and the other is heavier. Let's say we say the lighter body is body A and the heavier body is body B, and these two bodies are joined through a rigid hard rod. And let's say we mark a point O at any position between these two different masses of masses A and B. Let when we use the force at the point point O, which is nearer to the lighter body, we will see that the system will topple down. It will not rotate. It will not move forward. Rather, it will rotate. Hence, this position is not the center of mass. Now, move the point O towards the heavier body. You will see that system will move little, but it will also rotate backward. Hence, this is not also the center of mass of the body. So, when we adjust the position O such that when we use the force at this point and this system moves forward without rotation, then this point will be the center of mass of the object. So now we can define that center of mass of a system is such a point where an applied force causes the system to move without rotation. And the third topic, the center of mass, center of gravity. Again, I would like to give an example. We know that a body is made up of large number of particles. Earth attracts each of these particles vertically downward toward its center. The pull of the earth acting on particles is equal to its weight. These forces acting on the particle of a body are almost parallel. The resultant of all these parallel forces is a single force equal to the weight of the body. A point where this resultant force acts vertically toward the center of the earth is called center of gravity of the body. So now I will define the center of gravity, a point where the whole weight of the body appears to act vertically downward, is called center of gravity of a body. Now I will explain the center of gravity of different uniform objects, mean different regular objects. Here 6 objects are described. The one is the square and the rectangle, circle, ring, triangle, and the sphere. And the center of gravity of all these objects are described here. And center of gravity of a uniform square or rectangle is the point of intersection of their diagonals, and center of gravity of a uniform circular disc or a ring is the point of intersection of its diagonals or diameters. And center of gravity of a solid sphere or hollow sphere is the center of sphere. It also is a axis of rotation, which is found by joining the two centers of the circles at the top and the bottom of the cylinder. This axis of rotation. There is also a point of a center of gravity at the middle of the axis of rotation. The regular objects which are in front of you on this slide, the first one is the square and third one is the rectangle, and the center of gravity of these two objects is at the center point of intersection of the diagonals of square and rectangle. The second is square and the fourth is the ring. The center of gravity of these two objects is the center of intersection of the two diameters. And number 4 is the triangle. The center of gravity of this irregular shape is the intersection of its median. And the last is the number 6 is the cylinder. The center of gravity of this object is the center of the two circles at its end, and the line joining these two centers is also the axis of rotation of the cylinder. Center of gravity becomes a little higher. It returns to its stable state by lowering its center of gravity. A body remains in stable equilibrium as long as the center of gravity acts through the base of the body. Consider another example, a block. When the block is tilted, its center of gravity rises. If the vertical line through G means center of gravity, passes through its base in the tilted position, the block returns to previous position. And if the vertical line through center of gravity gets out of the base, then the block does not return to its previous position. It topples over its base and moves to the new stable equilibrium. That is why a vehicle is made heavy at its bottom to keep its center of gravity as low as possible. A lower center of gravity keeps it stable. Moreover, the base of the vehicle is made wide so that vertical line passing through its center of gravity should not get out of its base during a turn. Now at the end I will define stable equilibrium. A body is said to be in stable equilibrium if after a slight tilt it returns to its previous position. I have given the two diagrams as well. The first, as I already quoted, that the example of a steering. The second, the example of the spanner used when you are changing the tire of your car. You are using the couple. And the next type of equilibrium is stable equilibrium. Unstable equilibrium. Again, I will start from an example. Consider a pencil and try to keep that pencil in the vertical position on its tip. Whenever you leave it, pencil topples over about its tip and falls down. This is an example of unstable equilibrium. Hence, in an unstable equilibrium, a body may be made to stay only for a moment. Thus, a body is unstable, unable to keep itself in state of unstable equilibrium. Hence, now we can define unstable equilibrium. If a body does not return to its previous position when set free, After a slightest tilt, it is called unstable equilibrium. The center of gravity of a body is at its highest position in state of unstable equilibrium, and as the body topples over about its base, its center of gravity moves towards its lower position and does not return to its previous position. Now students, the last type of equilibrium is neutral equilibrium. Again, I would like to explain through an example. Now take a ball, for example tennis ball or football, and place this ball on a horizontal surface. Roll the ball over the surface and leave it after displacing from the previous position. It remains in its new position and does not return to its previous position. Such a type is called neutral equilibrium. In a neutral equilibrium, all the new states in which a body is moved are the stable states, and the body remains in its new state. In neutral equilibrium, center of gravity body remains at the same height, irrespective to its new position. There are various objects which have neutral equilibrium, such as a ball, a sphere, a roller, a pencil lying horizontally on the surface, an egg lying horizontally on flat surface. These all are example of neutral equilibrium. And now at the end I will define neutral equilibrium. If a body remains in its new position when disturbed from its previous position, it is said to be in state of neutral equilibrium. And I have given these diagrams as well to explain the stable equilibrium, unstable equilibrium, and the example of balls, the neutral equilibrium. At the last, I will give you a recap of the lesson. Today, we discussed the topics principle of moments and defined the principle of moments mean when the clockwise moment and anti-clockwise moments are equal. And the next topic was center of mass, mean the point when the force is applied at that point the body moves without rotation. And the next was the center of gravity, mean where the point of the system where whole weight of the body appears to act. The next was the couple, mean two unlike parallel forces of the same magnitude but not along the same line. And next was the equilibrium, and equilibrium mean when the sum of all forces is zero and sum of all the torques is zero. And the next were the types of equilibrium: the stable equilibrium, unstable equilibrium, and neutral equilibrium. And students, hopefully you will have understood all the topics, and you will prepare the worksheet given separately in the folder. Okay, thank you. Allah.